Day 590 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 2147, number of ways to divide a long corridor. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. Along a long library corridor, there is a line of seats and decorative plants. You are given a zero-index string corridor of length n consisting of letters S and P, where each S represents a seat and each P represents a plant. One room divider has already been installed to the left of index 0 and another to the right of index n-1. Additional room dividers can be installed. For each position between indices I-1, where I is 1 is less than or equal to I is less than or equal to n-1, at most one divider can be installed. Divide the corridor into non-overlapping sections where each section has exactly 2 seats within any number of plants. There may be multiple ways to perform the division. 2 ways are different if there's a position with a room divider installed in the first way but not in the second way. Return the number of ways to divide the corridor. Since the answer may be very large, return it modulo 10 to the 9th power plus 7. If there is no way, return 0. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, our input corridor equals a string SSPPSPS. The output is 3. Explanation says there are 3 different ways to divide the corridor. So what this output means, this 3 means that we could just divide this corridor 3 different ways so that there are at least 2 seats in every way that we divide it, right? So it says, and we could look at this picture that they give us up here. It says the black bars and above indicate the 2 room dividers already installed. So right here it says 1 room divider has already been installed to the left of index 0. That's this black line right here, and another to the right of index n-1. That's this black divider right here. Boom. So that's what that's talking about. Then it says note that in each of the ways, each section has exactly 2 seats. So they give us this picture up here that we can use, and they show us the 3 different ways that we can divide it. And you can see that there are 2 seats, and each way we divide it, there are 2 seats on each side. There's 2 seats on this side, 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 2 seats on this side. It says right here that each section has exactly 2 seats with any number of plants. So that's why we need 2 seats on each side. And just so I can show you working with the with the input, let's just do it over here so I can give y'all a visual representation as well. And I'll show you the 3 different ways we can divide this output, right? So these S's represent a seat. Each one of these P's represent a plant. So first we could put a divider right here, boom. And as you can see, let's just say this dash is the divider, right? So as you can see, if we put the divider right there, then we have 2 seats on this side and we have 2 seats on this side. Boom, one right here and one right here. And it says we can have any number of plants. So we're not worried about how many plants there are on each side. Boom. Then coming right here, we can also divide it like this right here. Boom. So we still have 2 seats on this side, and we still have a seat on this side and 2 seats on this side, right? A seat right here and a seat right here. And then also we can also divide it right here. Boom. And if we divide it right here, we still have a seat right here and a seat right here. That's 2 seats on this side. And then we have a seat right here and a seat right here. That's 2 seats on this side. And in total, we were able to divide this room 3 different ways, or this corridor, I should say, 3 different ways while still keeping 2 seats on each side. And that's why the output is 3. So this picture is just a visual representation of this right here. Boom. So just in case that didn't make sense, let's go ahead and take a look at example 2. So in example 2, we have an input corridor equals to the string PPSPSP. The output is 1. It says there's only one way to divide the corridor by not installing any additional dividers. Initially, any will create some section that does not have exactly 2 seats. So in this case, the only way we can divide it is just leaving it with this divider here and this divider here, meaning we don't add any of our own dividers, right? Because we need 2 seats on each side. So if we put a divider right here, we'd have 2 seats on, let's bring this over here so I can show y'all. But if we put a divider, say we put a divider right here, we would still have 2 seats on this side, but not 2 seats on this side, right? And then also, if we put, say we put the divider right here, boom, we would have 2 seats on this side, but no seats on this side. So that wouldn't work either. So the only way we can do it is to keep these dividers as is, with 1 to the left of 0 and 1 to the right of n minus 1. And that just counts as one way to divide the room, right? So these 2 dividers counts as their own way to divide the room. Boom. I don't know why they don't up here, but hey, we all know how LeetCode is. So either way, there's only one way to divide the corridor by not installing any additional dividers. Boom. Then in example 3, we have our corridor S, or I guess the one way is to not add anything. That's the one way. So that's why we're up here. We would, that one count, because if we didn't add anything, then there would be 4 seats, and we want 2. So that's the difference that I was trying to explain up here. If we didn't have, say we didn't add these blue lines, these dividers would not count as their own, because then we would have 4 seats. So that's why we need to add these, so that we only have 2 seats on each side. Boom. And in this case, we only have 2 seats. So that's the only way to divide the room, and that's where that 1 comes from. Now in example 3, we have an input corridor equals a string S, meaning we have 1 seat and the output is 0, because the explanation says there is no way to divide the corridor because there will always be a section that does not have exactly 2 seats. So in this case, we only have 1 seat, so it's impossible to divide the corridor any type of way to give us 2 seats, because we're missing a seat. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Solution is not that difficult at all. Now, first thing we want to do is we want to count the total number of seats in the corridor. So we're just going to declare a variable. We could call it valid, and we'll set that equal to corridor dot filter, open up the brackets. We're going to say $0 equals, open up the quotation marks, passing S, then we're going to say dot count. So what this is going to do is this is going to go through corridor and filter out every S that we see in corridor, and then we're going to count those S's, and that's going to allow us to see how many seats we have in our input. Boom. Now there must be more than 1 seat, and the number of seats must be even, otherwise it's impossible to split the corridor correctly. So that we'll use a guard statement for that by saying guard, open up the parentheses, we'll say valid is greater than 1, meaning we have more than 1 seat, and we'll say 2 and signs, valid mod 2, so mod 2 equals 0. So that means this will let us know we have an even number of seats, because if we don't have an even number of seats, once again, then we won't be able to divide the room into, so that there's only 2 seats. And then we can say else, open up the brackets, and we can just return 0. Boom. Now we need to get the number of seats encountered in the current segment. And so for that, we're going to say var s count, set that equal to 0 just to start. Then we need the number of plants between the 2 seat pairs. So for that, we can say comma p count, and we can set that equal to 0 just to start. And then we need the total number of valid ways to divide the corridor, so we can store that in result, and we'll set that equal to 1 just to start, because once again, in case we get something like example 2, we could just set the default value to 1. Boom. Now we need our modulo value, right? We need to handle this 10 to the 9th power plus 7. So we could just say let mod equal 1 underscore 000 underscore 000 underscore 007. Boom, just like that. Now we're going to iterate through each character in corridor. So we're going to say for char in corridor. We're going to open up the brackets and we're going to say if char. So if that char is equals, open up the parentheses, pass in a capital S. So if we come across a seat or a capital S, then we need to see if S count equals 2, meaning there are 2 seats, then we have already seen a pair of seats, and the number of ways to place a divider depends on how many plants were between this seat pair and the next. So we could just say result equals, open up the parentheses, we'll say result times, open up the parentheses, p count plus 1, come outside both of these parentheses and we'll say mod, just like that. Then we need to reset our counters for the next segment, so we're going to come underneath that and say s count equals 0, and we're going to say p count equals 0 as well. Now we need to count this seat from right here by coming underneath this if statement, and we're just going to say s count plus equals 1. Boom. Now we're not done yet, because we're going to come right here and we're on this if, and we're going to say else if s count equals 2. Boom, then we're going to count plants only after exactly 2 seats have been found. So we can say p count plus equals 1, and we're going to return the total number of valid ways to divide the corridor by coming right here, and we are going to say return result, y'all. Boom. Sorry, y'all. Boom. That's all she wrote, y'all. Let's go ahead and give it a run. Make sure it runs properly before we submit it. Let's see, it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. And look at that, y'all. 215 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.